Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge. Find first palindromic string in the array. Okay, so what this says basically is we get an array of words, and we want to find the first word that is a palindrome. Okay, so basically palindrome reads the same way forward as backward. Essentially, you can think of it if we take this example, race car here, which is a palindrome because if you take a look, if you start reading from here and start reading backward, it's the same way. So we read R first, and here we read R first, we read A first, second, we read A second, after that we read C, after that we read C here, after that we read E for both, and here we read C for this one, and then we read C for this one, we read A for this one, and A for this one. So you can see this one is a palindrome. So how do you check it? Well, the easiest way is just to reverse it. So for example, if we reverse this string, we'll get the exact same string. So if this S is equal to reversed S, then that means it's a palindrome. And so that's exactly what we can do. We can just go through every word and just check if it's a palindrome, right? So that's what we can do here. So to check if it's a palindrome, we can just check that it's equal to its reverse. In Python, you can do reverse using just this, and then you return the first one you find that there is a palindrome here. It says that if we don't find a palindrome, we should return an empty string. So that's what we'll do here. And we can run this. It looks good. We can submit. And it passes. Now, in terms of time complexity, this loop here runs n times, n being the length of words. This loop here, because we reverse every character and compare, we reverse W and compare every character, so it's the length of each individual word. But if we want to we want to get the worst case scenario, the worst case scenario is the longest word in the list of words. So let's call that just the length of that m. And so overall, this means this overall is of n being the number of words, and m being the length of the largest word in that list. Okay. Now, a different way we can do this, if we want to do it like just iterate over the characters and just compare, like exactly what we did here, which is basically compare the last one with the first one, compare the one at position 1 with the one at position n-2, the one at position 2 with the one at position n-3, and you get the idea. So basically compare each one with the one in the opposite direction from the end. So how do we do that? Well, we just can, we only need, by the way, to compare the half, because let's say, for example, we compare this one and we compare this one, right? This comparison, if we go past half, so for example, this position, which is 0, 1, 2, 3, 4, 5, 6, for example, position 4, then the other pointer for going from the right would be at 2. And we already did this comparison when this pointer was at 2 and this pointer was at 4. So no need to do it again. So we can actually just stop at half. So divided by 2, we do +1 just so that it actually ends at the middle. And now we can just compare. If the character at position I is different than the character at position, the length of the word minus I minus 1. Now, why do we do this? Because we want to compare, so the first position 0 with position n-1. That's what we want. And here is 7, so with position 6. Then we want to compare position 1 with n-1 minus 1, n-2, which is position 5, which is exactly what we want to do here. Okay, so that's the idea. So that's why we do it like this. Now, if this happened, this means W is not a palindrome. Okay, so how do we mark that? Well, let's just initially, before checking, let's have this boolean to check. Initially, we assume it's a palindrome until we find evidence that it's not. And so here we found an evidence that it's not, because two characters that should have been equal are not. We can set it to false. Now, at the end of checking for W, we check. If it's a palindrome, then we can return it, because we only need to return the first palindrome. Okay, so we can run this and submit, and this works. This is also the same time complexity as the previous one. Of course, it's slightly optimized because we only go through half. We only do half m iterations. But one other thing to think about here is that there is a trick here for this indices. Instead of writing this long one here, to sort of write that you want just the symmetry, so I from the right instead of I from the left, you could actually just do it like this. This will give you basically, since this gives us the position I from the left, this will give you position I from the right, which is basically just n minus I minus 1. And so if we try this, it does work and gets accepted, okay? Yeah, so I think that's pretty much it for this problem. Just wanted to cover 2 solutions so that you can learn something new, like for example this one here. Thanks for watching and see you on the next one. Bye.